Hi, I am Tanajan and I will be attempting math homework question 3.
So the question asks us, suppose you are climbing a hill whose shape is given by the equation z is equal to 1000 minus 0.005 x square minus 0.01 y square, where x, y and z are measured in meters, and you are standing at a point with coordinates 60, 40 and 966. The positive x-axis, which is east, and the y-axis is which is north, is positive. The first part of the question asks, if you walk due south, will you start to ascend or descend, and at what rate? To answer this, we need to find at what rate we are ascending or descending. This we can do with the formula of directional derivative, which is directional derivative f x y is equal to the gradient of the function and its unit vector. The vector which we will be traveling in this part is due south, which is negative, so which can be written as minus j because it lies in the y-axis. Now its unit vector, uh, the unit vector will be equal to the vector by its magnitude. In this case, being negative j cap and the magnitude being 1, which is again minus j cap, which is the unit vector. Now to find the gradient of the function, which will be equal to del f by del x plus we'll also add I cap, del f by del y j cap, which is then equal to minus 0.01 x I cap plus 0.02 y 0.02 minus 0.02 j cap. Now we'll substitute the value of the point we were at in the gradient, which will be f 60 40 is equal to 0.6 I cap plus, sorry, it will be negative, and then minus 0.8 j cap. Now substituting the vector of which direction we'll be going in, so that will be minus 0.6, then 0 plus minus 0.8 minus 1, which is equal to 0.8. The directional derivative is 0.8. We know that as du is more than 0, we know that if we walk due south from the point 60, 40, 966, we will be ascending the hill. The second part of the question asks, if you walk northwest, will you start to ascend or descend, and at what rate? So again, if you're taking this north, east, south, west, and it says that we're going northwest, which is directly in between north and the west, so we know that it will be exactly at 45 degrees from both axes. This vector can be rewritten as vector, the magnitude of the vector u, and then cos 45i because of the x-axis, it is 45 degrees from the x-axis, 45 I cap plus magnitude of the vector sine 45 j cap.
this again can be rewritten as taking the magnitude as a common factor, and then we're substituting cos 45 to be negative 1 by under root 2 I cap plus 1 by under root 2 j cap. Now we will be converting this vector into a unit vector. For this again, what we'll do is unit vector will be equal to the vector itself by the magnitude, which is minus 1 by under root 2 I plus 1 by under root 2 1 by under root 2 j cap. Now we'll consider the gradient of the function which was given initially. At the point 6040, which is 0.6 negative 0.6 I cap plus 0.8 j cap. Now we'll take the directional sorry for the weird cut. As I was saying, we know that the directional derivative is given by the gradient into the unit vector. So for the second question, it will be the directional derivative will be 0.6 negative 0.6 into 1 by under root 2 plus 0.8 minus 0.8 into 1 by under root 2, which will be equal to minus 0.2 under root by under root 2, which is again minus 0.141. As you can see that the directional derivative for the vector is negative and is less than 0. So at that point and traveling northwest, we are descending the hill as du is negative. Just wanted to add one more thing. I'd forgotten to answer the second part for both A and B. So for A, we will be ascending at the rate of 0.8 meters vertical meters per horizontal meter, and for the second part, for the B part, we will be descending the hill at the rate of 0.141 vertical meters per horizontal meter. Now for the last part of the question, in which direction is the slope largest? What is the rate of ascent in that direction? At what angle above the horizontal does the path in the direction begin? So for that, we know that the slope will be largest in the direction of the gradient. So we already know what is the gradient, so we will convert that into a unit vector. So it will be minus 0.6 I plus 0.8 j cap, and then squaring 0.6, that will be 0.36 plus 0.48 0.64, which will again this will be equal to 1, so it will be minus 0.6 I cap plus 0.8 j cap. Now for the directional derivative du, which will be gradient into the unit vector, that will be 0.6 into 0.6 plus 0.8 plus into 0.8 0.6 into 0.6, that so du will be equal to 1. We know that as du is positive, we will be ascending the hill. So we know that du is equal to 1. So to calculate the theta at to calculate the angle above the horizontal, what we'll do is we'll take theta to be tan inverse, and then we know it is 2 minus 1 is 1, 2 minus 1 is 1, which is written here, and then theta is equal to 45 degrees.